coming in, there's 16, but there'll probably be a few more.
Okay, I will get started then. And
Hello, welcome to IIUG session 2021. In this session, we are going to discuss about integrated backup encryption into the Informix. So yes, first question will arise is that why encryption will be required into the backup. So it will help to enhance the security of the information we are storing into the database. And yes, we wanted to protect our customer data and our private information. Like even the small leak of the information will have the terrible implication to our customer and the partners. So of course, we wanted to store our customer data with highest level of the security. Backup encryption is dangerous. Encrypted backup can be dangerous if you misplace your encryption key, then you are in a deep trouble. Like when we are using the encrypted backup and somehow we misplaced or somehow we lost the encryption key, then there is absolutely no way to restore those backups. So simply those backups are not usable again. Those will be useless to our system. So we have to protect our encryption key, or we have to keep our encryption key very safely. So main reason to delay integrated backup encryption, that is the user provide only the encrypted encryption key, likely that we will mishandling of the keys and backups will be rendered as unusable. So just like I explained, so whenever we are using the encryption key, the major concern is to protect the encryption key. Without the encryption key, we are not able to decrypt the backup. So the backup will be unusable if we misplace or we lost the encryption key. And so the formal method of backup filter was good in the sense of operator will need to be involved in all decision involving the encryption. Like previously in version 11.10, Informix implemented the feature of backup filter. It is more commonly used to compress data, but that feature we can transform data into the compressed form or the encrypted form before we back it up. So long backup Informix does support the encryption, but yes. So, there is one trick involved with this method, that it is complex to use the backup filter, as user will be involved in a very closely in all the decision making. Like the user has to generate the encryption key, user has to manage the encryption key, user has to store the encryption key at a very safe place. It takes a lot more energy to make the backup filter method to use. So we provided this is in a very early version, but yes, this is simply used to compress the data. It is simply used to encrypt the information. But yes, if we are opting in for the backup filter, then user or a DBA has to have to involve in a more like in all the phase. Like it will be their responsibility to generate the encryption key, manage the encryption key, and store the encryption. If somehow they misplace it, then again, as I explained, the backup will be unusable. Envelope encryption. This is and we are going to use the envelope encryption into the integrated backups into the on-web. So integrated backup encryption uses a technique called as envelope encryption. With the envelope encryption, all information that is necessary to perform the decryption process and does not compromise the security of encryption is stored together with the encrypted object. The envelope tells us if the backup is encrypted or not. The algorithm used the initialization vector and the encryption. So when we are talking about the encryption envelope, it means simply we are storing all the required information together to decrypt the object as well. Like what is the encryption key is there, what is the algorithm is used, if the backup is encrypted or not. So all those information stored together. Like the question will arise, if we are storing the encryption key into the envelope itself, so does it vulnerable to foreign attacks? No, because we are encrypted that encryption key as well. So it is not in the simple format. that anyone will be able to read. So we are encrypted that encryption key again using the one of the root key. So EK is the generated using the remote key store. So generating the EK means we are using one more root key to wrap it up. So unwrapping of EK reverse the envelope encryption process by using associated root key, resulting in a decrypted and authenticated decrypted encryption key. So wrapped decryption encryption key cannot be unwrapped without the associated root key, which will add an extra layer of a security to your data. So obviously, when we are encrypting the encryption key itself, then we are adding one more layer of security to our data. The remote key server provides access using the set of credentials that must be available to backup client at the backup and restore side. So there should be the access to the remote key store to get the encryption key or to get the encrypted encryption. So at the time of taking backup or at the time of restoring the backup, we should have the access to the remote key store. So in this, there are two methods we are going to discuss in those are regarding bar method 1 and bar method 2. So these methods will are more focus on how to use the remote key store. Like in first method, we are using the Amazon remote key store. Into the second method, we are going to use the Azure Key Vault method. Using the Amazon, we are using the Amazon remote key store, and into the Azure, we are using the Azure Key Vault. Like Informix, I think started supporting Azure Key Vault into the 14.10 X2 release. In those systems, we are managing the customer key, remote key, or the encrypted key. That keys never leaves their location. Like that, master key never leaves the their system. It is always stored into their system only. It is not going to transfer to any other location. So always there will be there will be no chance of losing any keys there. So our keys are always safe and easy to retrieve. In case of Amazon, data encryption key is going to encrypt the backup or encrypted data. So in case of Amazon, encryption key is going to encrypt our data that Amazon has the service to generate the encryption key. So Amazon remote key store has provided the method to generate the encryption key, that is the data encryption key or the encryption key into their system. So this encryption key is going to encrypt the backup data. So this encryption key will be used to take the backup data with the encryption. Suppose if we don't wanted to use the Amazon service to generate the encryption key. So if we don't wanted to use the Amazon remote key store generate method, then there is a one alternate way. Like that way is to use the OpenSSL service locally into the IDS logs. So encryption key can be generated locally if we don't wanted to use the generate method of remote key store. So we have to use the OpenSSL service locally to generate the encryption key, and that same key will be used to encrypt the data. To generate the encrypted encryption key, the same key, encryption key is the input to remote key store. That encryption key will be remote to the encryption key will be input to the Amazon's remote key store, and it encrypts the key, and then it will get the encrypted version of a encryption. So it will provide the encrypted encryption key, as encryption key will be also encrypted using the master key. Here, like previous slide, I explained that we are encrypting the encryption key with the root key again. So that is the master key. So encrypting the encryption key with the master key, we are providing to the IDS box. It will call it encrypted encryption key. Now in IDS box, we have two information available. We have the data encrypted and we have the encrypted encryption key. So which we are going to put into the envelope of backup. So backup itself knows what encryption key use, what is the algorithm is used. If the backup is encrypted, so all the information is available into the envelope itself. So this bar method 2 is a method of replacement method for the bar method 1. In this method, we are using the Azure Keyword Store. And yes, as I explained, Azure Keyword Store Informix started supporting into the 14.10 XE2 release version. So difference between the method 1 and the method 2 is that we cannot generate the encryption key at a remote key store. Like if you focus on the method 1 and focus on the method 2, then we cannot generate the encryption key at a remote key store into Azure Keyword. So we have to generate the key locally, and on-bar generates the encryption key. So in this case, we have to generate the encryption key locally, and on-bar generates the encryption key. So locally generated key will be act as the input to remote key store. So we will send that locally generated key to the remote key store. So this encryption, then again, a remote key store will encrypt the data with the master key, and they will provide us back the encrypted encryption key. So yes, whenever we are using Azure keyword, then the key encryption key will be generated locally. That will act input to the remote key store, and remote key store again encrypt that key using the master key. It will provide the encrypted encryption key to us. Like in this case also, we will put all the information into the envelope. So in IDS box, we will have the information regarding the encryption data and the encrypted encryption key. So both information will be put into the envelope, and yes, of course, all the required information will be available to decrypt the object. So this is the overall architecture of encrypted backups into the Informix. Like if we say we have the backup media, so backup media can media or the backup of a database. In this, we have the encrypted encryption key, and we have the encrypted data. So if you think overall perspective, then suppose my backup is encrypted using the encryption. So at that end product will be I have the backup media where my in envelope we have the encrypted encryption key and we have the encrypted data. So envelope is going to tell us about if the backup is encrypted, if what kind of algorithm is used, what is the encryption key is used, and the next, if the backup is encrypted, then next blocks of data will show us that if information is encrypted or not. So EK is generated using the AES, that advanced encryption standard. So input to the advanced encryption standards is the master key and the encrypted key. So the EK is generated using the master key of remote key store and using the encryption key. So both will act as an input, then it will produce the encrypted encryption key. So similarly, if we see the lower part of a flow diagram, so it comes the backup data to the advanced encryption standards, then to the input as AES, and the encryption key as a input to AES. So we are encrypted backup using the encryption key, then the output will be the encrypted data. So it will clearly show us how the encryption works in Informix. It is to generate the encrypted encryption key that generated using the master key of a remote key store. It can be the Azure or it can be Amazon. So AES will encrypt the encryption key using the master key, and that will be stored into the envelope as a EK. And the data will be encrypted using the encryption key that will be stored as an encrypted data blocks. bar encryption. When we wanted to use the bar encryption key, we have to need to set the bar encryption configuration parameter, the same parameter used by the on-tape and on-bar. So for the on-tape and on-bar, there are no different parameter provided. If you want to use the encryption for the on-tape as well and on-bar as well, then single parameter is sufficient. We just have to set the bar encryption value to the key store and what algorithms we are using for the encryption. This parameter is similar to the disk encryption. They support the same cipher as the disk encryption. So AES 128 or AES 192, AES 256. These are the three encryption algorithm is supported by the Informix. Those are the strongest one. We can use an advanced encryption standard 128, advanced encryption standard 192, and we can use advanced encryption standard 256. The key store option point to the GS kit 12 file created using the utility of on-key store with the type of AWS bar. So key store option will point to the file created using the on-key store utility. If you see the in this case we are using the Amazon, so it is the key store is pointing to the on-key store file with the kind of what encryption we are using. Like in this case, we are using the 256. That information is provided. Bar decryption key store value. Oh. This is the optional configuration parameter. Bar decryption is used during the restore. During the restore, bar decryption can be used to override the bar encryption. That is to use the backup taken with a different set of credentials. Bar decryption does not accept the option cipher because the cipher always stored into the envelope. So whenever we were using the bar encryption parameter, we are giving the which encryption algorithm where we are using. But for the bar decryption, it is not at all required to provide the what algorithm we are using. But as I previously explained, we are using the envelope encryption. So all the required information is already present into the envelope. So there is no need to specify. If we are specifying the cipher into the bar decryption, it is considered as an error. Using a local encryption key, yes, as we said, managing local encryption key is potentially dangerous. Our customer do require using them in a many scenarios. Like so, there are so many scenarios we have to use the local encryption key. We don't have to use the key generated using the RKS or remote key store. So in this case, there is also one method provided. We can point the key file location to the local. Like previously, we were giving the information about the key store. Now we have to give the information to the key file and it will point to the local key. We provide the option of using the local encryption key, but we make every effort to make it clear to use that we are not managing the key. We do not even help creating the encryption key. In this case, encryption key is not stored into the envelope. So as I explained, major disadvantage of using the local encryption key is that if we are not storing that encryption key somewhere. So it is the DB or user responsibility to generate the key, store the encryption key at a safe location. If that encryption key somehow misplaced, then it is the backups will be unusable to restore it. So yes, whenever we are using the local encryption key, then just we have to provide the bar encryption parameter key file to the locally generated key. Then we will have the physical path of local key, and then what encryption algorithm is using. In this case, we are using AES 256. Local encryption key file. Now we will discuss about the information about local key encryption file. The local encryption key is a text file. It must be owned by a DBA owner. Must have the permission 600. The key must be stored into the file-based format, 64 format. So in this case, when we are creating the encryption key locally, then it is a simple text file. then it must be owned by the DBA owner, and the permission to the encryption key file must be the 600. The key must be stored into the base 64 format. So in this scenario, in this case, we are generating key with a 256 byte. We are generating the key with a 256 byte with 32 bit as a length. So if you want to use 182 bytes of key, then we have to put 24 there. And if you want 128 bit key, then we have to put 16 instead of 32. Storing your credential to access the Amazon remote key store, you need to store your credential to access the Amazon key in GSKit PKCS12 file generated using the OnKey store. The easiest way to do it, that put your credential into JSON file and then ask OnKey store to generate the output file. So of course, when we wanted to store the access to Amazon the remote key store, then we need to store our credential into Amazon GSKit 12 file generated using the OnKey store. So we can provide the input to the OnKey store as a JSON. It will give the file generated with the required credential. Changing encryption key. If you are using the key store option, the encryption key is changed every time you invoke ONTAP or ONBAR. Like if we are set the parameter of bar encryption to the key store, then at every time we are invoking ONTAP and ONBAR, the encryption key is automatically changed. If you are using the key file, then encryption key it changes when you change the content of the key file or the point to the new file with a different key. So like when we wanted to be pointing the bar encryption to the locally generated key, then encryption key change only when we are changing that value. In both cases, we must be thoughtful about at what moment the parameter key store or key file is changed, as doing this could be render the decryption of old backup not possible. Like user should have more aware about at what time we have to change the value of encryption key. Like if you wanted to use the backup previously used, then users should keep in mind that they should not change the key before the restore. So the best time to change the bar encryption is before taking the level 0 backup. Like if you wanted to change any encryption key, then the best time considered as if we change the encryption key just before we are starting to take the backup. Like if I have the backup take with suppose level 0, 1, 2 with the encryption key 1, and I wanted to change that encryption key to encryption key 2. Then the both best moment to change manually the value of bar encryption is just taking the full backup, like taking the next level 0 backup. The reason is that you will be able to restore the level 0, level 1, level 2, and any logs taken thereafter using the same value of bar encryption or bar decryption. So, as I explained, if we change the encryption key, then best time is to change for the level 0 backup itself. So there won't be any problem to restore the level 0 or level 1 or level 2 backup. Changing the bar encryption or decryption in the middle of restore is not easy. You will need to split each restore separately steps and do appropriate changes to the onConfig file manually. If we change bar encryption between physical backups, logs backup, before the change may not be restorable with the new setting. If you suspect, you may need to multiple settings of bar decryption to restore logs, and logical restore must be started using the continuous log restore option so that any failure in recovering the log makes the engine wait for user to input. This will give us time to change the bar decryption and restart the log. So consider it, we have the couple of backups which we need to restore with the encryption key 1, and which another backup we need to restore with the encryption key 2. In this case, we have to do some manually changes. So first we have to set the restore value into the config parameter. So if the restore fails, then it can be restart from the last successful place. So suppose we have to put the bar decryption value first with the first key, then those objects which are encrypted with the key 1 will be decrypted. When the on bar restore fails, then again we have to change the bar decryption value to the key 2. Then again, as we set the parameter of restart, restore into the config parameter, then it will start decrypting the object with the encryption key 2. So it will be successful to restore. By using the remote, now we will discuss performance versus security consideration. By using the remote key store, you need to consider that you will need to contact the key store between 1 to 3 times for every object that we backup and 1 time for every object we decrypt. Although the communication will be RKS is very short, still slower than just reading the key. So whenever we are talking about using the remote key store, yes, of course, it is obviously slower than using the local file accessing. But the advantage is that we are at a more safer location. Like there is a safe location to store that our encryption key with the encrypted format. Also, the decryption process will slow down the speed of backups or the restore. The performance penalty will vary from machine to machine. So whenever we are decrypting the process, it will have the slow speed of backups or the restore, because we have to first decrypt the data with encryption key. Then of course there will be the degrading performance, and that performance is penalty with penalty of having the security. So performance will vary from machine to machine. This should not be the problem for most of the system unless very short log files are used, which is most in case is not recommended anyway. So if we are not using the short files, then there is no issue regarding it. Backup process will generate a single encryption key during its life. If the process is generating multiple objects, for example, a single object process is running serially on the on-tape process, backing up the logical logs to directly, we will use the same encryption key for each object. Like consider it that whenever we are taking the level 0 backup, we have the multiple objects to backup. Like we have the DB space 1, DB space 2, DB space 3. There are multiple DB space. So whenever we are encrypting the DB space 1, then only one single key will be used during the lifetime of encryption of all the DB spaces or all the back objects. So single key will be used over throughout the life of encryption of on bar or on tape. So all the objects, like in simple format, all the objects took into the backup will have the single encryption key. However, the initialization vector will always different from each object. Different remote key store has a different behavior. Like as like previously we discussed about the 2 remote key store, that Azure and Amazon. So every remote key store has a different behavior. How we read the data from remote key store, how we put the data into the remote key store. So those calls will vary from one remote key store to the other remote key store. Using a JSON credential file, this is the undocumented feature that can be used to do the quick test. Instead of using a key store option, you can use a JScript create with the point to the text file and containing the credentials. So instead of using the key store option, we can use the JSON format, simple JSON format to do the quick test. Yes, that's all for today current session. If anyone has any question, please let me know.
Okay, we can open up the questions now.
Just put them in the chat. If you have any. There are a few other experts in the room that can probably help if since the Amol, the presenter, is not here. Do you see that one, Karen?
I do. Maybe an example. Yeah, that would probably help. So do you have an example of using Azure RKS? I'm sure we can create one if we don't have one, so possibly. So I will take that as a note.
And Kevin and Tom are both in the room. At
Okay.
least they were. Maybe they might provide guidance.
Yeah, I was thinking the same thing, Vicente, where we could do an article or we could post to the Informix community page some examples, or publish an article and then point to the examples that we published somewhere. So that would be a good idea.
Yeah, or the Insider, that's true.
Yep.
That would work too.
Okay. Thank you for the feedback. Good feedback.
Anybody else? We will start back up at 1:10, so you have almost a 25-minute break.
Yeah.
Okay, thank you, everybody.
Yeah, there is an article on the community, IBM.com, from JC that talked about Azure and key store. So I don't know whether any information there might be useful, but it's for encrypted key storage. So
On the community page?
yeah, most of it was related to, I think it's got encryption at rest. So I don't know whether that includes any of the bars. Yeah, it's got the bar encryption stuff in it. So, but I don't know if the examples there call out anything specific to Azure. It doesn't look like it, but it's another location.
Okay.
It doesn't look like it's
We can talk to
providing.
JC in the next session because he's on at 1:10. What's new in the kernel? If you want to try to sideline him beforehand or during or after. But not to want to hijack his session, but it's sort of about the kernel.
Yeah, we'll have to. I think we'll have to provide some examples, in a separate, white paper or something like Karen was suggesting.
Anything else? All right. We'll see you all at 1:10 or so here elsewhere. Take care, y'all.
Thank you, John.
Thank you very much. Bye.